I think the first thing that comes to anybody's mind is stuff that flies and probably space. I think that's a very simplified way to explain aerospace.
Whatever heavy things you can think about, you can make them fly if it's perfectly aerodynamic.
Every single time you see a plane in the sky, that's aerospace engineering. Every single time you wonder, I don't know, a SpaceX, a Starlink, all that is aerospace engineering.
Imagine yourself lifting yourself to the sky. That's what aerospace engineering is.
It is the study of the development of aircraft, rockets, satellites, pretty much anything that flies.
Hi, my name is Amelia.
Hi, my name is James.
Hi, my name is Khushi.
Hi, I'm Reva.
I'm a first-year engineering student.
I'm a second-year student.
I'm a third-year student.
I'm a fourth-year aerospace engineering student.
And this is my perspective.
And this is my perspective.
And this is my perspective.
And this is my perspective of aerospace engineering at TMU.
First year is very general. You're going to be with every other discipline. There's just one course we take just aerospace students. There's Aero 222, and that's engineering design. We are taught how to draw stuff. I like drawing, but that's like technical drawing. You get to know a lot about the thought process behind all that, because our final project was to design a foldable chair for an airplane. It had to be accessibility for people in a wheelchair, so you can strand the wheelchair to the airplane. If that is not being used by a wheelchair user, is a normal seat. Actually got us thinking for such a long time, because we were like, how can we make it this easy to use because it's an airplane, safe, and like how? It really got me thinking on like the engineering process of like solving a problem is a lot of work. I think most of us didn't actually sat down and think how much of a responsibility it is. You're not just preparing to know about the stuff you like, build stuff, like how this works. It's not just that, the work you do, the life of people will be in the line. I realized how big of a responsibility and how important it is to be ethical about your work. You meet a lot of professionals here. All your profs are people that are well versed in their engineering. That's so great because it really got you thinking of like how many paths are actually there for engineering students. You can stream to so many places and do so much. Because the first year is common, you have the opportunity to talk with every other engineering. It gives you an idea of how it will be your profession afterwards, because you're not gonna work alone. You're always gonna work with other engineers. I make very good friends. If you have friends that you can rely on, that's like a lifesaver. They're gonna be like, did you eat? Did you do this? Did you drink water? Do you have a class? For me, that was like the most important part of it, making people I can rely on.
Specialization in aerospace engineering consists of 3 choices. Spacecraft is mostly satellites. It's a lot of orbital mechanics, basically when you're not on Earth. Aircraft is everything when you're still on Earth, so planes, rockets. Avionics is very complicated electronic stuff, so a lot of operating systems, ground systems, just electrical systems all around. The stream that I specialized in was aircraft. Planes are cool, rockets are cool. The course that helped me decide my specialization, there's 2 courses actually. The aerodynamics course, just because it was a lot of study of airfoils and structures. I just found it very interesting. And when I took this first circuits course, I did not like it. I was very bad at it. I just realized this is not something I want to go into. That's pretty normal. You'll have a certain class that you just really don't like, and it helps you decide. I use a lot of CATIA. You start using MATLAB a lot. Some courses let you use SolidWorks, a lot of 3D modeling. Student groups at TMU, the 3 that I am most familiar with are Met Rocketry, Mars, and MOC. They're basically the liquid rocket team. Met Rocketry is more focused on large-scale rocket. It's one large rocket that they take to competition and launch. And Mars is smaller scale competition using L1 rockets, which are the little guys. You basically have a team of 4 or 5 people and you build your own rocket and compete against each other. So both very cool. They're all very casual because they're all run by students. It's very friendly, it's very easy. I am a big part of Met Rocketry. I started as a general member on payload. I've now been promoted to the payload manufacturing lead. We are basically making our own system. We choose a mission, then we design it over the course of the year. It's really fun. I also help on a couple other teams, but it's very easy to join. Basically just talk to people, make yourself known in the chats, and you'll do very well. When I joined, I knew literally nothing. I just showed that I wanted to be there, and they recognize that, and they will teach you pretty much everything you need to know. They help you fill a lot of the gaps that learning leaves, because in the classroom you learn how to use SolidWorks and CATIA, all this stuff, but you don't apply it too much. Design teams let you really explore what you enjoy doing, and they make you really good at it, and it also just really boosts your resume.
Co-op program helps you gain experience. There's so many companies that actually sends you their job application in that portal, and then you can apply from the portal. There are technical positions, but there are also general positions. Now, there can be aircraft performance, product management, stuff like that. So it depends on which one you're interested in. I would say apply to all of them, because being too specific just in this one area only, it wouldn't help you get what you want. Get the experience, and then you can move on and get whatever you want to do. I got a job at Bombardier Recreational Products that makes ADVs, Ski-Doos, Sea-Doos. My position was computational fluid dynamics intern. When I heard about this interview, I was very scared. The interview was super technical for me. But in that technical interview, they're not going to ask you anything related to CFD. They were only going to ask you things that are going to be related to your understanding. That is a big thing. There's some interviews that are very behavioral. I had a behavioral interview and a technical interview. So it depends, company to company and position to position. In this role, you basically have a vehicle. You can see how the air flows around the vehicle. So you have to check everything. This does seem like, oh, it's a very small thing. It's not. You have to go through that heat management. There are thermal placements, there are aerodynamics that plays to a part of the vehicle, which is very important in terms of sending this vehicle out. You need to check that, hey, is the system too heated up? We need to put a thermostat there. We need to cool that system down. We need to cool that radiator down. It was a very cool, I love my job.
I always thought that, you know what, I will be making engines or like a part of the plane. But now I worked with different companies, Bombardier, with Pratt & Whitney, and Unilever. My skills have come with both making engines and having empathy in the room. As an aerospace engineer, it is important for us to think outside the box, because the world's changing. We have to have a sympathetic and empathetic mindset to make things happen. My degree taught me how to ask questions, how to start something from scratch. I am an international student. I was a very shy girl, wouldn't ask questions and would just copy paste what was written on the slides. Now it's so different, because in my 4th year I've been asking the right questions. We started off with CATIA, then in 2nd year with math lab and everything. While I was working in the industry, I started loving what I did. TMU laid the foundation for me. Now I'm leading conversations. I have a problem to solve. Space is becoming more gender inclusive, greener. I see myself being a part of that impact, which is not just about making something, but very human-centered and empathetic. Challenges that aerospace engineers face even today is keeping up with the fast-paced environment. There are a lot of people who are thinking smarter and faster by every single second. So there's an innovation with every second. Keeping up with that pace is important. I am really grateful for joining this university, because it has changed me as a person.
One thing that really got me into coming to TMU is when I visited the campus, like before classes. I came here and saw the engineering students look so happy. Like, I was like, they look like a family. They're all laughing. They're having like a good time together. Like, the TMU engineering community is one of the best things I've ever seen.
I love this program because it had space in it.
I really love everything that is related to space, stars, telescopes, and all that, so I knew my path had to be there.
I feel like this is the most creative engineering disciplines to be in. I always loved the idea of becoming an astronaut, but I never thought that, hey, you can build a rocket to make the astronaut fly to space.
I used to skate next to the airport, and I used to see planes fly. and I wanted to first become a pilot. COVID hit and a lot of pilots were losing their jobs. And I was like, you know what? Before I learn how to fly these machines, why don't I learn how to make them?
It's really interesting stuff. It's really fun.
I think it's the ripple effect that excites me the most. You're just not making engines or building a plane or making a rocket. You are leading change.